Hello there. In this video we'll be going through how to use the tracker program to determine the acceleration due to gravity by dropping a ball from a certain height. On the task sheet for the gravitational acceleration practical, if we scroll through, we'll have the method for the experiment where we need to capture a video of someone dropping a ball vertically, just downwards, with a meter ruler in view of the camera as well, and the eye line of the camera, if you like, should be perpendicular to the ruler and perpendicular to the ball being dropped as well. That's very important. Let's pay special attention to the video formats you should be using for your phone, or even better, instead of using a camera, if your laptop has a camera built into it, just use that and just try and get the eye line of that camera nice and perpendicular to the ruler and where the ball's being dropped. Once you've taken the video, try and transport it to your laptop through like a cloud server or something, and then download it onto your laptop. An example of a video that you might be using is I've just got one here that I've got preloaded and pre-done that I've downloaded. So in mine it just looks like this. Someone just drops the ball, and that's all I need. So that's my video that I'll put into Tracker. Tracker from the homepage. You want to download one of the installers, whether it's Windows or probably a recent Mac operating system, and then follow the instructions there to download the program somewhere that makes sense for you onto your laptop. Once you do have it downloaded and open it, this is the screen that you should see. And the first thing we want to do is load our video into this program. The easiest way to do that is probably to open the file location yourself, and then to drag and drop it into the video space, and then that should load it in like so. Now you may notice that the video loads in with the wrong orientation. That's okay, we can fix that. If yours is pointing the wrong way, all you need to do is go up the top where video is, filters, new, rotate, and then do the correct rotation. And I want to rotate it 90 degrees to the right. Sorry, wrong way. I want it to go that way. 90 degrees to the left. And then that's it. I can close that, and now it's the right way up. Have a little bit of a play on the bar down the bottom, so I can play the video, and then frame by frame it will drop the ball. I could even scrub through the video by going backwards and forwards through the different frames. Importantly, it tells you what frame it is sitting on the left here. And we can also use these arrows keys to go back frame by frame in the video for some really fine tuning, which is very useful. The thing we want to do is we want to find the point in the video where the person releases the ball. So I can scrub through to find the approximate point in time where that is. So it's about here-ish. And then I'm going to use these two to just fine tune the exact point when they release it, which I think is about here. And then I'm going to go over here and see that that is frame 25. I want you to click on the frame number and say set time to 0. And then it should start reading just 0, 0, 0. And now that point has been labeled as 0, as in like a start time, because we're interested in when the ball is being dropped. And then we're going to set that as the start of the video. So we're going to grab this arrow and drag it to that time for when they release the ball. So I'm looking for when this reads 0. So right now it's negative 0.033. I go over 0. I want it to be exactly 0. And that means I've got the correct frame, so that now when I press start, it just starts it from when the ball is being released, which is what I want. The other thing I'll do is I'll drag back the end of the video, because I'm not interested in the whole thing. I'm just interested in after the ball gets released, and then down, down, down. And I don't really want when it hits the ground either, so I'll just go to about that point in time there. That's good enough, and I'll leave it like that. So now when you click this arrow and rewind back to the start and I play, It just plays the bit of the video that I want to analyze. Okay, now I've got a video I can analyze. I need to give it a coordinate system so that it knows which way is up, which way is down. Over here we've got our toolbar, and I want to click this one here that looks like some axes. If I click on that, these are X and Y axes. You can click on that and move it around, and you should have your video set that up and down is up and down. So we should be able to just leave that. You don't need to set the origin position anywhere special because we're going to be looking at velocity. So just make sure that it just looks like coordinates, like an X and Y axes, and that's fine. Now we need to tell the program what a meter is. This is where the meter ruler comes in handy. So over in our toolbar, we're going to use this tool here, which looks like it's blue, and it's got like a line in it and a number with 1.0. I'll click on that and go new calibration stick. This should appear, and it says 1 meter on it. I need this to align with the meter ruler. So I'm just going to place the two and drag them around until they're over the meter ruler. And if I want to be really precise, I can even zoom in and just get it exactly right. I do recommend you do zoom in and just get it so that it's sitting on the ruler, and now the program knows exactly how long a meter is so that it can calculate distances and velocities correctly. Okay, now comes the important part. I'm going to rewind back to the start of the video when we're holding the ball, and now I'm going to track the motion of the ball frame by frame. To do that, you probably guessed that we need to track. So you're looking for the track tool, click on that, click on new, and click on point mass. You'll get a graph start to appear. I'm just going to close that, and what we're going to do is we're going to click on where the ball is in each frame, and I do want to zoom in to make sure I'm nice and accurate. If you hold down shift, your arrow changes to this little box, and you're going to place the box over the ball and click on it, and when you click on it, it should advance to the next frame. Keep going, clicking on the ball, holding down shift all the time, like that, and it's disappeared, so I'm just going to scroll down so I can keep an eye on it, like so, all the way down until I'm finished. Keep going, like that. And it didn't advance, so that's the end of the video. And now I've got a nice graph as well on the side showing its X and Y position, I think, is the default. And now I'm just going to zoom out again. This time, if you kind of rewind it and play it, you can see that it's tracking the ball through its path. Okay, now that I've tracked its motion, I just want the graph side. I'm just going to move this over so I can see its mass, and right now it's displaying its X and Y position. But what we want to see is how its velocity is changing over time. If I look at its Y position, I can see that its position is changing. So it starts at position 0, and then it moves through to position minus 1.6 after this much time has passed. So I know that's fallen through like 1 meter and 60 centimeters after that time has passed in the negative direction. If I can change this to look at the different aspects of the ball's motion, so you can have a bit of a play and see graphs of different aspects of the ball, but the one that you're interested in for this prac is the velocity Y component. If I click on that, I can see a fairly linear decrease in the ball's velocity, starting from 0 all the way down to 5 meters per second downwards, that -5 there, and that's after this much time has passed. So that graph is fine, but it's not handy to analyze. We want to take this data and export it into Excel so that we can make it look nice and produce lines of best fit and things like that. So what we really want is a table of the data. So we want time and we want velocity y, velocity for up and down. Under columns, click on that, and I'm going to uncheck the X and Y box, and I will check the VY blocks for velocity up and down for the Y component. I'm just going to close that, and now I've got two columns for my data showing its time and the velocity that the ball is going at. Now this data, I'm going to highlight it, so just click and drag, highlight all the data, and then right click, and I'm going to go copy selected cells as formatted. So copy selected cells as formatted, that's very important. Otherwise it will chuck it into scientific notation, which we don't want at this stage or at all. I'm going to paste the data in Excel. So pasting it in there, boom, there's all the data in Excel now. With time, which I'll just relabel as time in seconds, and I'll relabel that as velocity in meters per second. And at time 0, I know it's got a velocity of 0. So I'm just going to add that point of data in there. Delete this one that's at the end. And now using this data, you can paste that into your prac report. For the data table is put your data in there. You can make it neat. And to graph it, I'm going to highlight all the data. Then up the top, go insert. Under charts, you want the chart with the dots on it for a scatter plot. So click on that, and then just do the first one, the simplest one. Click on that. And then there is a graph of my data. Now, the first thing you probably notice is that the graph goes down. It's like in the negative quadrant of your Cartesian plane. It's below the y-axis, but don't panic about that. These values here for the velocity are negative because the ball is going down, and that's the negative direction. So that's why the graph is below the x-axis, is because the velocity of the ball is down. And if you look at your data, it's all in the negative as well because the ball is going down. That's the negative direction. If you really don't like that, you're welcome to change all these values to positive values, and the graph will be in positive, and the velocities will still be the same. But that's it doesn't matter if you don't do that. It just you can please yourself there. I'm not too concerned about that. To produce a line of best fit, I'm going to over here click on the plus sign. I'm going to check the box that says trend line, and I also want to see the equation of the line of best fit. So I'm going to press the side arrow and just go more options. A toolbar should appear on the right. Just move over for a sec. And then I'm going to scroll down and check the box that says display equation on chart. Once I've checked that, I should get an equation for this line of best fit. And that's it, we're done. If it didn't make any sense, if you're stuck anywhere, just make sure you let me know. Don't leave your chart like this though. Make sure you add like an appropriate title, things like axes labels. So you can click on the plus sign and just go axes titles, and then you can record this as like the time in seconds. Here you can go velocity in meters per second, like that. And the chart title should describe what's going on. So it might be the velocity of the ball over time, or velocity versus time, or something like that that's describing what the graph is showing. I want this stuff in my report, so I'm just going to copy the data, and then in here I need a lot more rows than that, so I'm just going to create heaps more. And then in there I'm going to paste, and that chucks the data in there. Don't need those. Don't forget to do the subheadings there, and enter in the graph as well. One last thing, remember to copy and paste the graph. Do not paste an image of the graph. So if I copy and paste the graph from Excel, I can actually edit it. And that's it. Thank you very much for listening. See you later.